Hello, welcome to my channel about electric heating boilers. Today, we'll talk about the grounding. Why do you need it? The purpose of grounding is to remove hazardous voltage from the electrical device surface and to ensure that protective systems are activated with a minimum delay. As you know, there are only single-phase and three-phase domestic electric power systems, and there is a great variety of grounding systems. There are several protection systems up to 1 kV described in electrical engineering regulations: TNC, TNS, TNCS, IT, and TT. The first letters indicate grounding parameters of the power supply source, which is the transformer station supplying the alternate current to the consumer. T stands for the grounded neutral conductor. I means the insulated neutral conductor. The second letter indicates the grounding type of appliance's exposed parts. T means that exposed conducting elements are grounded. N indicates that conducting elements are connected to the grounded neutral conductor, while letters C and S describe the state of zero protective conductors. C means that they are connected. S stands for the separated conductors. Let's see how the electricity is supplied to our homes. The consumers are powered by power plants generating three-phase, low-voltage alternate current. In order to reduce losses during long-distance transmission via power lines, the voltage is increased to several hundred kilovolts by means of step-up transformers. After that, the substations reduce the voltage to 380 volts by means of step-down transformers. Later on, electric current is supplied to our homes via three-phase or single-phase, low-voltage circuits. Three-phase power supply is carried out via three-phase conductors and one neutral conductor. The voltage between phase conductors equals to 380 volts, while the voltage between each phase and neutral conductors sums up to 230 volts. If this type of circuit is used, the load must be uniform for each phase conductor. If the circuit being used is single-phase, the electricity is supplied by means of two wires, one phase conductor and one neutral conductor with the 230 volt voltage between them. To understand the way a grounding system works, let's draw a transformer substation circuit, in which the electricity is supplied to the consumer via three-phase conductors, L1, L2, and L3. The circuit also includes PEN conductor, which stands for the protective earth and neutral conductor. We shall also draw a residential scheme that includes an input switchboard, a three-phase automatic circuit breaker, and a bus to which the conductors coming from the transformer substation equipment are connected. The domestic circuit will include a three-phase and a single-phase consumer. These three-phase conductors are connected to the three-phase consumer by means of the automatic circuit breaker. Only one phase conductor is connected to a single-phase consumer. Now, let's see how three-phase and single-phase consumers are grounded in different grounding systems. First, let's consider the TNC system. The TNC is a system where the transformer substation neutral conductor is solidly grounded, while three central cores, L1, L2, L3, and a PEN conductor enter the house. The PEN conductor is both a protective and a neutral conductor, connected to the electrical appliances enclosures. Only two wires are connected to the sockets, while enclosures are connected to the PEN conductor. This kind of protection is referred to as neutralizing. In the event of an emergency contact of the phase conductor and electrical appliances enclosures, a short circuit occurs and an automatic circuit breaker cuts off the voltage. It is a widespread system which is used in most residential homes. However, protection grounding is not meant in this circuit. What are its disadvantages? Since the neutral conductor is constantly loaded due to the electric current flow, it can either burn out or break off. Due to the jump of voltage, the appliances often go down and lose their protection grounding. Therefore, an electric shock occurs when a person contacts electrical envelopes. How can you protect yourself in this case? You can only do it by installing an RCD, or residual current protective device. The advantages of this system are its simplicity and cheapness. On the other hand, it does not meet modern safety requirements. Now let's talk about the TNCS grounding system. At the moment, it is a very common power supply system. Just like in the previous case, its neutral conductor is solidly grounded in the transformer substation. The PEN conductor in the input device is divided into 0 working and 0 protective conductors. Furthermore, the PE bus is grounded once again. All the domestic appliances are connected by means of a conductor through the PE bus. In this way, a 4-core wire consisting of 3 phases, L1, L2 and L3, and a PEN conductor is used into the domestic input device in the TNCS system, while 5-core wire consisting of 3-phase N and PE conductors enter the house. In case of a single-phase circuit, 3 wires, namely phase, N and PE conductors, come into the house after dividing the PEN conductor into N and PE elements. It is strictly forbidden to connect them inside the house. Moreover, PEN and PE conductors must not be broken by any automatic circuit breakers. You can only break the N conductor circuit. The disadvantage of this system is the formation of hazardous voltage in the PE conductor and consequently in all electrical envelopes, which are connected to it, in case the PEN conductor is damaged between the house and the power source. Therefore, proper PEN conductor protection along its entire length and grounding at the main ground bus are required in this system. The advantages of this system are its low cost, reliability and 0 breakdown protection. For these reasons, the system is preferred for the residential house use. Next, let's discuss the TT grounding system. It is used if it is not possible to protect the PEN conductor within the TNCS system. This circuit can be described in the following way. This conductor is solidly grounded at the substation power supply source. While power cable inside the house has 4 cores, 3-phase conductors and a functional 0 conductor. The exposed conduction parts of the appliances are grounded by a pin-type ground terminal. For this system, you must carry out a thunderstorm protection measure and install an RCD. Now let's talk about the TNS system. It is the safest power supply system, where 0 protective and 0 working conductors are separated along the whole length of the circuit, since the separation of 2 neutrals is carried out in the transformer substation. 3-phase voltage is supplied via 5 wires, while single-phase voltage is supplied by 3 wires. This system provides a very high level of safety. In case of working zeros burnout, the electrical appliances envelopes remain grounded. Regardless of the neutral conductor state, protection against electric shock is provided. However, this system is not commonly used due to its high cost. You need 5 wires in case of a 3-phase connection, while a single-phase connection requires 3 wires. Lastly, we'll discuss the IT grounding system. Here, the power supply source neutral conductor is grounded by means of the higher resistance equipment. In other cases, it can be earth insulated. There is no functional neutral conductor. A minimum number of wires is used to supply the consumer. All conduction elements of the electrical equipment are grounded. This system is used for emergency lighting in hospitals, laboratories, or special purpose entities. I hope you liked the video and found it useful. Please share your ideas. Press the like button below and subscribe to the channel not to miss new interesting videos. See you soon. Bye.